Section 5.2, Proving trig identities. Problem 3. In this problem, we are asked to take what looks like a very complicated expression here and show that it equals 5. There is no set rule to say approach it this way, approach it that way. But in looking at it, we do see that this is a perfect square and this is a perfect square. And it appears we might remove those. So let's say that x squared minus 4 would be factored down into x minus 2, x plus 2. X squared minus 9 would be factored into x plus 3, x minus 3. And now we see that x minus 2 cancels out, and x plus 3 cancels out, and we're left with x plus 2 minus x minus 3 would be equal to x plus 2 minus x plus 3 equal 5. And this is what we were asked to show. Section 5.2, problem 16. We want to prove the identity that tangent x plus secant x is equal to cosine x over 1 minus sine x. So let's change the tangent and secant into the sine and cosine, because that's what the left-hand side looks like over here. The definition of the tangent of x is the sine x over the cosine x. Definition of the secant of x is 1 over the cosine of x. We're working just with the left-hand side. We want to see if we can get it to look like the right-hand side. The common denominator of these two is cosine x. So we get the common denominator cosine x over 1 plus sine x. It's sine x plus 1, and I've reversed it to show something in a second that I see coming up. Now when I look at it, and I have 1 plus sine x here, and I have cosine x on bottom, to get a cosine x on top, I need to multiply by cosine x. So I need to multiply this by cosine x over cosine x. Which is just 1, so I can multiply this by 1. And have cosine x over 1 plus sine x over cosine squared x. Now I have the cosine x on top, but I have 1 plus sine x and 1 minus sine x here. But I recall that cosine squared x plus sine squared x is equal to 1. So I can change the bottom of this, leave the top the same, to 1 minus sine squared x from this equation. Cosine squared x would be 1 minus sine squared x. Now, leaving the top the same, I see that the bottom is a perfect square. 1 minus sine squared x would be 1 plus sine x, 1 minus sine x. The 1 plus sine x cancels out on top, and I'm left with cosine x over 1 minus sine x, which is what I desired originally. Now, how does one know the steps to go through? Yeah, probably you do not. One does not. You simply try and work from the left-hand side, if that's the more difficult, to try to get it to the more simpler side, which sines and cosines considered more simple. And you begin to look at it and see what takes shape. Once I got to this point, I didn't actually see exactly how to do it, but I said, let's get a cosine on top. Once I put the cosine on top, and had a cosine squared on bottom, then I began to see, because I recalled this perfect square, and that's only going to come with practice. Section 5.2, problem 29. The cotangent squared x minus cosine squared x. Show that that is identical with, or an identity with, cosine squared x, cotangent squared x. Let's start with the left-hand side. Cotangent squared would be the cosine of x squared over the sine of x squared minus cosine squared x. How did I know to do that? I do not. I'm starting with the left-hand side and changing it into sines and cosines, which I can manipulate and see more readily. Now I notice that both of these terms have cosine squared x in it. So I'm still on the left-hand side. I have now cosine squared x, 1 over sine squared x minus 1. By definition, 1 over the sine squared of x is the cosecant squared. So I have cosine squared x, cosecant squared x minus 1. Recall our identity, that 1 plus the cotangent squared of x is equal cosecant squared of x. Quickly in my head, I see that cotangent squared x is equal cosecant squared x minus 1. So now I have cosine squared x. This whole term is a cotangent squared of x from this part right here. And that was what I sought to prove from my identity. In first looking at this, I would think I would start with the right-hand side and equal the left-hand side. But let's do this particular problem both ways and see how we would approach it. So let's start with the left-hand side. I have cosine fifth x. Since I know I need to wind up with a cosine x on the right-hand side, I will pull out the cosine x and have cosine fourth x times the cosine x. Now I need to make cosine fourth x look something like this. Cosine fourth x is cosine squared x times the cosine squared x, and then I still have my term. I'll put parentheses around it just so you can see I'm just carrying it along. I know want that in the end because it appears here. I have cosine squared x. The identity I know is the cosine squared x plus sine squared x equal 1. So this cosine squared x is 1 minus sine squared x. 1 minus sine squared x, and then the cosine x that I'm carrying. Now do the multiplication of these terms, and I have 1 minus 2 sine squared x plus sine fourth x all times cosine x, and that is equal to the right-hand side. Now look at section 5.2, problem 48. I have this very complicated expression equals this very complicated expression, and I want to prove the identity. Where do I start? Well, actually, here's how I start. I recall that the sine squared x plus cosine squared x is equal to 1. The sine squared x then would be 1 minus cosine squared x. I could factor the left-hand side and have 1 minus cosine x 1 plus cosine x. That, in my mind, I have gone through these steps, and that lets me see that I have a chance to make the bottom side look like 1 minus cosine x because I have it here tied up in sine squared x. This simply takes some practice, and until you get that practice, just go through little steps like this, maybe on the side or working the problem. So now let me rewrite the left-hand side. I have 1 minus 3 cosine x on top minus 4 cosine squared x. And on bottom, I have this term. I have 1 minus cosine x, 1 plus cosine x. And I see that the 1 minus cosine x already matches, so I at least have that part of it done. Now let's see if I can factor the top. The top looks like 1 minus 3t minus 4t squared, where I've let t equal cosine x. If I use the star method to factor it, I put the product 1 times minus 4 here. I put this term here and over on this side. And I put the b term minus 3 down here. And now I ask the question, what two terms multiply together to give minus 4 and add to give minus 3? That means one of the terms has to be minus 4, the other one has to be plus 1. Because they add together to give minus 3, they multiply together to give minus 4. That leaves me with my factors being 1 minus 4t and 1 plus t. Looking back, t was the cosine of x, so I have 1 minus 4 cosine x, 1 plus cosine x. So the top factors into 1 minus 4 cosine x, 1 plus cosine x, 1 minus cosine x, these terms factor out, and I'm left with 1 minus 4 cosine x over 1 minus cosine x, which was what I desired in the beginning. How does one know how to do this? Just practice and looking at the problem. And sometimes you go down a back alley and just can't figure out where you are, and you approach it a different way. But experience will help. Plus, I did think that this had to be factored, and I did see the relationship with sine squared. So I quickly was on the right track to solve this.